Good morning, first period algebra class. I'm glad that several of you who were out are back with us today. I want to draw your attention that we are on the same learning target from yesterday. Section 6.2, I can solve systems of equations using substitution. Now I have gotten some folks to volunteer to put problems on the board for us. So those of you who are watching the video, be patient with us as we put these problems on the board and go through the explanations. I am going to record as the students are working. Just a reminder to everyone in the room, video is rolling. If you are not supposed to be on video, then please don't volunteer to work a problem. If you don't want your voice on the recording, make sure when you're talking, you're mouthing your answers to me so that we can still participate with class. Now, a big important part of this is questions, and yesterday went very well, I thought. Y'all participated, you asked questions, we got a lot accomplished, and I want the same thing today. I want the people who are watching our video at home to hear your questions because they may be thinking the same question, but they can't answer. So, that being said, I had some volunteers who said they would work problems on the board. So if you will go up to the board and start working your problems. I'm going to make you YouTube math famous. Go ahead. Go ahead. And students who don't, the problems that students don't work, I'll work for you. And I want to continue with this discussion today. You might want to scoot down just a hair, Molly. And I do want to say thank you to Molly and Macy. I'm going to make you math famous on YouTube. Molly's working number 9 for us, and after she gets it worked, she's going to explain it. And then Macy is going to explain. Oh, I didn't tell y'all were going to have to explain them on camera too, did I? Mean old math teacher.
They're not when you use their disguise.
Their disguise voices. Right or wrong? Right or wrong? I like it when my students go to the board and work problems because that lets me see what you're thinking. And if you made a mistake on something, somebody else may have made the same mistake. And by working it out on the board, we can learn together how to make corrections.
Come on, Molly, you can do it.
Let's see. You have solved for x. We also need a value for y. So what are you going to do with that number for x? Choose an equation?
It's a plug and chug.
Yes, ma'am. I would go with that one. Alright, and what did you end up getting? 213, and that's for number 9? That's correct. Alright, so let me get you to explain your process there, Molly.
Okay, I plugged in where it said y. I plugged in 4x plus 5, and I finished it out with equals 17. And then I combined my like terms, which gave me 6x plus 5 equals 17, and then I subtracted 5, and that gave me 6x equals 12, and I divided by 6, and that gave me x equals 2. And then for this one, I chose a equation to plug x equals 2 into. So I used the first one, which was 4 times 2 plus 5, which is 8 plus 5. and that's 13.
And you are correct. You are correct. Now tell me one thing though. Can you tell me what that ordered pair or the point 213 means for this system of equations? Can you tell me what 213 means? It's the what? Solution. Solution. It's the solution. What that means is that ordered pair is the intersection of the two lines. Like we graphed them and we saw where two lines intersected. This ordered pair is the intersection. It is the one solution where these two lines would cross. Thank you very much. All right, Macy. Your turn.
Okay. Well, I did this one. I got this equation, and I plugged this part in right here for the lockout, and I subtracted 2, so it's made it 1x, so it's negative 5 equals 1x minus 2. Then I add 2 to both sides, so it ends up being negative 3 equals 1x. Divided by 1 is negative 3 equals x. Then I got that 3, put it into the x on this equation, so it's y equals 2 times negative 3 minus 5. It equals y equals negative 6 minus 5. That ends up equaling y minus negative 11.
Very good. And your ordered pair is?
Negative 3 and negative 11.
And what does that ordered pair mean for your problem?
The solution?
It is the solution. And what is the solution?
I don't know.
You don't know? It's where if I graph those two lines, they would intersect. Okay? When our goal for these problems is finding the solution if there is one. Okay, so what we've done with these two problems is we've solved using substitution method, and we have found an ordered pair that is a solution for both problems. Another thing that solution means is I could plug, in Molly's problem, I could replace x in both equations with 2, and it's going to satisfy the equation, so long as I replace y with 13. So I replace x with 2, y with 13, it's going to equal the same thing on the left side and the right side of the equation. Same thing with Macy's problem. It is the solution for the system of equations. It is the one intersection of these two lines. It is what satisfies the equation if I replace x and y in both equations with negative 3 and negative 11. Okay? Do we have any other questions, or do I have any other volunteers? We had 8 through 13. Do I have anybody else who would like to work a problem on the board? I know some of you are camera shy and you don't want to go in front of the camera, and I understand if you don't want to. One of y'all want to work one? Number 12? You want to work it? Well, how about if I talk you through it? If somebody will go up to the board and work number 12, I'll talk you through it.
I didn't know that there was one later. No, I don't even know the problem.
Y'all want me to? Would y'all rather me do it?
Yes.
Okay.
That way we understand it completely.
You understand it completely. I don't know about understanding it completely. Why is this thing? Whoever is watching this video, my students watching the video, I can't get it to go straight this morning.
Savage.
What if I can't work it? What if I can't work the problem?
We
got a problem. The world blows up.
Hannah, why are you
Y'all did good, and I know it's not easy. I don't like coming up here and working problems on camera either. Somebody said something to me yesterday. Does it not bother you being on camera? Yes, I hate it. I don't like being on camera either. but I know that it helps my students, so I sacrifice. Alright, so number 12 is the one you had problems with. Tell you what, call the problem out to me.
It's 2x plus y equals 3.
And
4x plus 4y equals 8.
okay, in order to use the substitution method, I've got to have a variable equal to the rest of the stuff. Do I have that in this problem? No. Can I easily create, or can I easily solve and make a literal equation out of one of these so that I can replace? Which one?
The top one.
The top one. Okay, so I'm going to take 2x plus y equals 3. What do I want to solve this for?
Y.
Solve for y. Okay, how do I solve it for y?
Subtract 2x from both sides.
And then what do I have after I subtract 2x?
Y equals 3 minus 2x.
Okay, now that I have gotten this solved, do you know what to do?
Yes.
What do I do?
Plug and chug.
Plug and chug. Plug it into the other equation is correct. Substitute this information in for y in this equation up here. Now I'm going to give y'all a minute to do that, okay? And then maybe somebody will feel comfortable with coming to the board and finishing up what we've done, what we've started. I'll give y'all a minute or two. Whoever's watching, I think we got 2 out today out of this class. So maybe between first period and second period, we can get all the problems worked on the board. Love hearing pencils. Y'all are doing an awesome job. Got your pencils working this morning. When I have somebody who feels comfortable and confident, go up to the board. Let's see what you got. Just think how proud your mamas and daddies are going to be to see you at the board as mere 8th graders working algebra. On YouTube for all the world to see.
My mom's proud.
Yes, I know your mom is. I know your mom's proud.
My mom's proud of me.
Volunteers.
She's proud of me.
Come on. Nobody. Okay, y'all talk and tell me what to do then. If I can't get anybody to come up here, you're going to tell me what to do. I'm not working this problem by myself. Four x plus 4 times what again? 3 minus 2x. Okay. Equals 8. Then what? Not quite. We got to do something else first. Distributive property first. Tell me how to distribute.
4 times 3.
Tell me how to hug.
4 times 3.
And that is?
12.
Uh-huh.
4 times 2x.
Is?
8x.
Don't forget your minus sign. Uh-huh. Equals.
8.
Okay, now what?
Plus 4.
Now, yes. Now I can combine like terms. Tell me how. Tell me what. Give me the deets.
8x plus 4x.
4x minus.
I thought you would subtract 12 first.
Okay, you can do that.
Do that first.
I'm alright with that. And then what do I have?
So you have 4x minus 8x.
What is 4x minus 8x?
Negative 4x. Equals 4. Negative 4.
Then what?
You divide by -4.
And x equals what?
One.
Good. Why is it positive 1?
Because negative divided.
Yeah, when I'm dividing two negatives, that's going to give you a positive. Yes,
What is that, 4x negative? I missed that step.
The 8x.
Here.
12 minus
Uh-huh.
8. So when you subtract the 12.
same signs add and keep, different signs subtract.
So you use the sign of a larger number than the big black.
Man, aren't y'all impressed with how deep my voice was? Okay, that's good. Now we know half the story. Now we know half the story. What do we do to find the other half of the story?
Get in.
Go back to either one.
Either or.
2, and what did I find x is? Plus y equals 3. Now what?
Wait, can you not use the y equals 3 minus 2x?
Yeah,
That's what I use.
Yeah, you can. It's better sometimes to go back to your original equation. The reason for that is if you've made a miscalculation somewhere. But if you've made a miscalculation, this is going to be wrong anyway, most
Yeah.
likely. So, yeah, we'll go here. Y equals 3 minus 2 times 1. And y equals 3 minus 2. Y equals what? 1. And let's see if we got it right. Number 12. The answer is 1, 1. But what does that mean? What does the answer mean?
It's the solution.
It is the one solution. It is the point where the two lines intersect. Yes. That's what I need you to understand. I mean, this is just not some random answer. It's not an answer. This answer means something. It means if I graph these lines, think about the calling card. We've talked about the calling card 3 days in a row now. The point at which that calling card companies offered the calling card and it was the same price for the same minutes was where the lines intersected. Okay? This would be looking at like the point where the calling cards intersected. This would be where they were the same price. Except we have a more abstract equation than a concrete example. Okay? So this point is where these two lines intersect. It is the one solution for this system of equations. Okay? Anything else? Okay, here's what I'm going to do. I'm going to give you the answers to these problems, and I'm going to give you a second or two. We've had 3 on the board. I'm going to give you a second or two to look at your answers and make sure that you have them correct. And if you don't have them correct, then we'll put up what you don't have, okay? Number 8, our solution is the ordered pair 1, 6. 1, 6. Okay? Number 9, Molly put on the board for us. The answer was 2, 13. That ordered pair 2, 13. Number 10, your ordered pair solution, big numbers. 29, 53, the ordered pair. 29, 53. Number 11, Macy put up for us. It was -3, -11, ordered pair. We just did number 12 together. It was 1, 1. Number 13 was -1, 0. Okay, is there a problem that you need to see? Is there any one of these? Because I want, yes ma'am.
Here.
Number 10. Okay, let's very quickly look at it. Would you call it out to me so I don't have to wear these silly glasses?
Yeah.
Okay.
Y equals 3x
Uh-huh.
minus 3,
Yes ma'am.
34. There was 3, 34.
Tell me
It's
that.
34.
34. Okay.
And then the second one is y equals 2x minus 5.
Minus 5. Okay, now the good news here is I've got y equals and y equals. So how can I start out setting this up to solve it? Think substitution? Think they're both saying y equals,
Just put 1 equal.
yeah, tell me how though.
Okay, so you put negative, or put positive 3x. Minus 34. Equals 2x. Minus 5.
Okay, now what?
You working out?
Mark what out?
No, working out.
Tell me how.
Okay. See, I would add 34 to each side. No. That's where I messed up. Right.
Let's go ahead and go with this.
Okay.
Let's see what happens, okay?
Alright, so you get 3x equals 2x minus 29. No? Yeah, minus 29.
Okay,
Okay. So you minus 2x for each side. And you get 1x.
or just x.
X equals negative 29.
Is that what the answer was? Did I call that?
Positive 29.
Positive 29? Let's make sure I didn't copy something wrong. Alright, when I've got,
I messed up where I added 34. Oh, my real problem, I subtracted 2x.
oh,
Yeah.
is this correct? What's wrong with this? What should it be? Plus.
Oh, yeah.
Yeah. Yeah. Is that what you did too? No?
I actually got it right on my paper.
I just went wacko on the board, right? Okay, so now that I know half the story, what do I do?
Okay.
Which
Okay,
one?
yeah. The
Either
bottom
one, doesn't matter. So tell me how.
I did the bottom.
Bottom one, okay.
Y equals 2x.
2 times what replaces x?
2 times 29 minus 5.
Uh-huh.
And that's 53. No. It's 58. 58 minus 5.
So y equals what?
53.
My ordered pair?
29.
29, 53. That's the solution to the problem.
That is the solution to the problem. What makes it the solution to the problem?
Where they intersect.
It's where the two lines intersect. These two lines intersect. It is where if I took 29 and replaced x here, and I took 53 and replaced y here, I get the same thing on both sides. Same thing here, if I put 29 and 53, I get the same thing on both sides of those equations. Somebody let our door close and put the stop in it so it doesn't close all the way.
What are they doing?
Alright, I want to give you a different situation now. I'm going to give you one and I want you to solve it. Plus 3y equals 4, and 4x plus 6y equals 9. Okay, I want y'all working on that one. Think it through. Think about what you got to do. Let me make sure I copied it correctly. Think about what you got to do on this one. You're going to have to make a literal equation. You're going to have to solve one of these for either x or y. Which one would you like to solve for either x or y? Which one?
I did the top one.
Top one? Okay. Let's go with the top one. So what am I gonna solve this for? X or Y? Solve for Y. Okay, tell me how.
Alright, first you subtract 2x.
Okay?
3y equals 4 minus 2x.
And
You divide by 3.
now, something that y'all have been doing when I've given you 5-minute quizzes and you've had the literal equations, y'all been drawing one ginormous line and doing that. Now, for these problems, you can still do that, but in the future, I think it's going to help you more and help you get answers more right if you divide each term by that 3, rather than drawing one ginormous fraction bar and putting that 3 in the denominator. You need to start drawing a fraction bar under each term and putting the 3 under each term. Okay, and then I've got y equals 4/3 minus 2x over 3.
Are you substitute that in for y on
Yeah.
6?
We're going to go up here and we're going to say 4x plus 6 times all this stuff. Right? So far, so good? Make sure that camera is picking this up. I don't know if I've got it set. Can you see this here?
Yeah.
Okay. Now what do I do? Y'all love fractions so much.
You need to do 6 times 4/3.
Okay, I'm going to bring this 4x down, just let it hang out with us for a while. And we do need to use distributive property. But I want y'all to get really good with fractions because you're going to have to deal with them from now till doomsday. So that would be 6/1 times 4/3. Simplify.
24.
And reduce.
That's 8/1.
8/1, which is just
8.
8. Okay, now do the next one. We got 6 times, I'm going to ignore x for just a minute. 6 times 2/3.
That's 12/3. That's 1. There's 4 over 1. There's 4.
Be what?
4x.
4x. And I've lost what it equals. Now what?
X. 12.
Subtract your 8 from both sides.
Subtract 8 from both sides? Okay. Now what?
4x minus 4x equals 1.
Ooh, does 4x
Equals
minus 4x equal 1?
8. Equals X.
It equals, what's 4 minus 4? What's 0 times anything? 0. So 4x minus 4x is what? 0 equals what?
That's one of those ones that, no solution.
Oh,
Yes! Ah! It is a no solution. I don't have to go any further. There is no ordered pair. There is no ordered pair on the face of the earth that will make this system have a solution. Now, if you've got your textbook open, I want you to flip back one page. Actually, I want you to flip back about 3 or 4 pages to the very first part of section 6.1, page 335. If you have no solution, what kind of lines will these two equations be? They're inconsistent, yes. But how do the lines look if I graph them?
Parallel.
They are. They're parallel. These two lines would be parallel lines. If I put them on a piece of graph paper, their slopes would be the same. Their y-intercepts would be different. Their slopes would be the same. The y-intercepts would be different. They are parallel lines. There is no solution. It is an inconsistent system of equations. No solution. They never cross. Never, ever, ever, because they're parallel lines.
What about, consistent, independent?
Let's look at one of those. Let's look and see what happens. I want you to make sure you understand this right here concept, okay? Let me go back over to the other page now. Let's try one more. Everybody got this down?
Yes.
Everybody understand, this system would end up being parallel lines. It is inconsistent. There is absolutely, positively no solution. Okay. And tutor says, what about the one that had one line, and what was it called? What'd you?
Consistent, independent.
Consistent and dependent. Let's take a look at something here. Let's try this one. X minus y equals 1. And let's try 3x equals 3y plus 3.
Yeah, make a little equation out of it.
Make a literal equation. Which one?
Say 3x.
This one?
Yes.
You sure?
Um,
It's a good one.
somebody
Go
else-
ahead.
Alright.
Go ahead.
I agree with you.
Go ahead. Somebody come on. Tutor's tired of talking.
Do it for X. You just divide everything by
Divide everything, every term, by 3. And what do I get?
bunches of ones and an X.
Y equals,
X.
not Y. Y,
X.
don't let me write Y.
X equals
Uh-huh.
Y.
Yes,
What's one?
okay, we're good.
Okay.
Now what?
Well, these would be the
Mine
exact
won't
same
be
as
so
those.
you plug it in.
Plug it in at the top. How? Tell me how you want to plug
Put
it.
it in, y plus 1. 1 minus.
Oh, that's all our numbers.
Minus Y equals 1. Oh, you already see something?
Yeah.
Okay, tell me what to do from here and tell me how you see it.
You minus 1 for each side. So that'd be Y. Minus Y.
Uh,
Y minus Y equals 0. 0 equals 0.
0 equals
Wow.
0.
2 eyes will equals face.
Sure. Okay. So what's the difference in this problem and the previous problem?
Previous
Both
problem had no
sides equal
solutions.
0.
These had infinite solutions.
This has infinitely many solutions. Why?
Because it's all our numbers.
Because it's all real numbers. This ain't a lie. The other problem lied to us. It said 0 equaled 8 or something like that, right? This problem ain't a lie. This problem is telling us the truth. 0 equals 0.
It's all real.
Now, if you flip back, it's all real. If you flip back to that same page that we just looked at, that graph in the middle, where it says, what does it say about it?
Consistent, independent.
It is infinitely many solutions. That means that you can pick your favorite ordered pair on the face of the earth. Doesn't matter what that ordered pair is, as long as it lies on that line, it's going to make it true.
Well,
If I graph this equation and I graph this equation, then they are going to be the exact same line on that graph. And you can pick any point that you want to that's on that line, and it's going to be truthful. It's going to give you x minus y equals 1. It's going to give you 3x equals 3y plus 3. Whatever ordered pair you choose that lies on that line. Okay? Now I'm going to give you 2 more problems that I want you to do. One is going to be infinitely many solutions. One is going to be a no solution, okay? I just want to see you practice with one of each of these and make sure that you understand and know the difference. So if you'll go back to page 347, I want to add problems 15 and 16. 347, numbers 15 and 16. Okay, students at home, get well soon, and I will see you back in class. Bye.